So remember that today is just going to be on the tricks of filling out our unit circle. I can't go any louder than this, so if you're choosing to talk over me, that's going to be your prerogative. So I ask you guys just kind of stay with me on this. First thing I would do is get a pretty generic color, and we're going to fill in our quadrantal angles. The angles 0, 90, 180, and 270. And you're going to see on this specific unit circle, you've got little lines where there are degree measurements, and that's the line that we're going to put our degrees on. So I'm going to start with 0 degrees. I'm going to go up to 90, over to 180, down to 270, and end at 360. And I will add an extra angle there for 360. So 0, 90, 180, 270, that's where I would start. Then, understanding that as we go through, that you have multiples, and if you understand that a unit circle is made up of multiples of the degrees. So for instance, the first angle measurement that I come to is 30 degrees. I'm going to use a different color for that. Is 30 degrees. And then if I take 30 and add 30 to it, what do I get? I'm going to skip the one in the middle because that's 45. If I take 60 and add 30, what do I get? 90. I already have 90. I take 90 and I add 30 to it, I'm back to 60. And I'm sorry, I'm back to 120. But you're going to use the same color that you're going to use for 60 degrees. I take 120 and I add 30 to it, and I get 150, and that's going to be the same color as my 30. 150 plus 30, 180 plus 30, and that's the same color as my 30. Go straight across. 210 plus 30, 240, and that's the same color as my 60. Straight across. 240 plus 30, 270. 270 plus 30, 300, and that's the same color as my 60. And 300 plus 30 is 330. So knowing that everything, and then 330 plus 30 gives me right back to 360. So knowing that I have multiples. Everything is a multiple of 30 degrees all the way around, excluding the 45. So now I'm going to go in and I'm going to fill in my 45, and I'm going to choose, this will be my fourth color. So I start out with 45 degrees. 45 plus 45 gets me to 90. 90 plus 45 is 135. 135 plus 45 is 180. 180 plus 45 is 225. 225 plus 45 is 270. 270 plus 45 is 315. And 315 plus 45 brings me all the way back to 360. Okay, so that's filling in my angle measurements by realizing that I have strictly factors of 30 and factors of 45, or multiples, I should say, of 30 and multiples of 45 all the way around my unit circle. Okay, so questions on any of those degrees? All right, so now strictly looking at my 30 and my 60s. I'm now going to fill in this little line up close to the edge of the circle is for my radian measurement. And so in my red that I have, I'm going to start, if you can count up to, what do I count up to, like 12? You've got it, okay? Or 16, you can fill in your radian measurement. In fact, you might even find the radian measure easier to fill in than the degree measure, because I start at 30 degrees with 1 pi over 6.
Is that the same color that you used for?
It's the same color that I used for my 30. All my 30 stuff is going to be in red. All my 45 is going to be in green. My 60 is going to be in orange, and all my quadrantals will be in blue. But you can choose whatever scheme that you want, okay? All right, now, don't get too excited to write something down quickly. Let me finish speaking before we write anything down. So this is 1 pi over 6, correct? I'm going to skip the 45s, they're on their own. If this is 1 pi over 6, 60 degrees becomes 2 pi over 6. But I reduce that to what? Pi over 3. The 90 then, I'm at 2 pi. The 90 then becomes 3 pi over 6, which reduces to pi over 2. The 120, I was at 3 pi, so now I'm at 4 pi over 6, which reduces to 2 pi over 3. I'm at 4 pi over 6. Now I'm at 5 pi over 6, which doesn't reduce. It just stays as 5 pi over 6, my bad. I come down to 180. I'm at 6 pi over 6, and that reduces to 1 pi. Seven pi over 6 does not reduce. Eight pi over 6 does reduce to 4 pi over 3. 7 pi over 6. 6, 7, and now we're at 8. The blue is 9 pi over 6, which reduces to 3 pi over 2. 300 is 10 pi over 6, which reduces to 5 pi over 3. I have 11 pi over 6, and that does not reduce at 330. And at 360, I have 12 pi over 6, which reduces to 2 pi. So understanding that we start by pi over 6, and then it's just a matter of counting by pi over 6s. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi, 5 pi, 6 pi, all the way around. And then you get it into reduced form, and then those are radians, okay? Same thing for 45s, except it's not pi over 6, it's 1 pi over 4. And always, even with our 30s, 60, 90s, our 45, 45, 90s, everything still includes the quadrantals when we count. So this is 1 pi over 4. This is 2 pi over 4, which reduces to pi over 2. Over here, I have 3 pi over 4. Then I have 4 pi over 4, which reduces to pi. 5 pi over 4 at 225. 6 pi over 4, which reduces to 3 pi over 2 at 270. 315 is 7 pi over 4. And then I make my full circle to 8 pi over 4, which reduces to 2 pi. Okay? So we've done our full radians. And if you can count by 1, 2, 3, 4, 5 and understand that I'm over 6 or I'm over 4, you've got the full circle filled in. Okay, now I'm going to zoom in strictly on the first quadrant. Because when you have the first quadrant with your points, you have the entire other circle, okay? But actually, I kind of jumped ahead a little bit. Let me zoom out just for a second. On a unit circle, my radius on every single one of these spokes is what is my distance? 1. So let's fill in our points on our quadrantals. So out here, I'm going over 1, 0. At 90, I'm at 0, 1. At 270, I'm at negative 1, 0. Not 270, it's 180. Down at 270, I'm sorry, is 0, negative 1. And then I'm back to 360 is my 1, 0. Okay, now the other thing I want to do is label and make sure that you understand that all students take classes. We did this yesterday in our notes, where this is an acronym for what is positive. Is it my sine, is it my cosine, or is it my tangent? What is positive in each one of these quadrants? So in the first quadrant, everything is positive. The second quadrant, only sine. Third quadrant, only tangent. Fourth quadrant, only cosine. When we go to fill in our unit circle, that is hugely important, okay? So what I want to do now is go back to our unit circle and do a XY plus or minus little chart. So in the first quadrant, this is all, which means that my cosine is positive, my sine is positive, and tangent's just going to be kind of float out here by itself. All trig functions are positive in the first quadrant. In the second quadrant, the A stands for all. Second quadrant, S stands for students. That means sine is the only thing that's positive, which means my cosine is negative, which is my first value, which is my x coordinate. Sine is positive, tangent is negative. I go to the third quadrant, and that's all students take. So it's a T, which means tangent is positive, which means cosine is negative, sine is negative, but tangent is positive. And C is for classes. Cosine is positive, sine is negative, tangent is negative.
Can you bring it back up to the first two?
So once we understand that, when we go to fill in our unit circle, if we nail down the first quadrant, you'll have all the rest. Because the first quadrant leads into the second, which leads into the third, which leads into the fourth. Our values, our numbers don't change, just the pluses and minuses do. And that's why we're color coordinated. So once we fill in for the 30 degrees, what our coordinate point is, then all the other ones, my color here is red, all the other ones then also will be those exact same numbers. The only thing that will change is the plus and the minus. All right? So what I want to do is I really need all your eyes down for a second. No, sorry. I want all pencils down. I want all eyes up here because this is critical. Okay. This is really kind of crazy with everything on here. This is what I've done for Algebra 2. And I want you just strictly looking at these points right here in the black. What do you notice is on the denominator? What number is on the denominator on every single one of them?
2.
A 2. So right now, using your colors as needed, I want you to make a fraction on every one of these points and put a 2 in the denominator. Okay? So every one of them has a 2 in the denominator. But what's special about 45? It needs to be a square root. That's the only little thing that you need to remember on that, okay? Okay, so we've got square roots. The rest of these are 2's. Now, if you go back to the one that's already filled out, look at my numbering here. Okay, all eyes up here. I go 3, 1, 1. And then I start all over again. 3, 1, 1. 3, 1, 1, 3, 1, 1. 3, 1, 1, 3, 1, 1. So I put a 3, a 1, and a 1. And if you are like, well, how do I remember square roots? They're all square roots. So that's the square root of 3. That's the square root of 1, but what is the square root of 1? 1. Square root of 1, which is 1. All right, now guess what? I do it all over again. 3, but I just go down. 1, 1. And again, everything has a square root, but the only one that really matters is the 3.
Wait, can you move over just a little bit?
Say that again.
Move it over just a little bit.
Okay? So every one of these denominators has a 2. Tangent is the square roots. I said that totally wrong. 45s are the square roots. Okay? 45s are the square roots. So 2, 2, 2, 2, 2, 2. On the 45s, I have my square roots. And then starting at 30, because that's where we start, 3, 1, 1. And then I just come right back down again, 3, 1, 1. And everything is a square root. But the ones that matter, since the square root of 1 is just 1, I don't need to show it. Okay? All right, now this is where the really important, the colors come into play. Because if you look up top, I have my oranges. My cosine for orange will always be 1/2. My sine for orange will always be square root of 3 over 2. The only thing that will change is it positive or is it negative? So what you can do now is using your colors, fill in all the oranges as 1/2, comma, square root of 3 over 2, and then appropriately, knowing all students take classes, putting in your negatives as appropriate. So I have here 1/2 square root of 3 over 2. And I know that sine is negative, so I will put a sign on the y value. And I wrote this up, or I'm sorry, I said that wrong. Sine is positive, so I put a negative on the cosine. And at 240, cosine is 1/2, sine is square root of 3 over 2. Both of them are negative because tangent is the only thing that's positive in the third quadrant. And in the fourth quadrant, cosine is positive, but sine is negative. And then go ahead and do the rest according to the colors that you have marked, okay? Yes.
So, and this is kind of the question, with 30 and 60, the cosine and sine are always going to be opposite.
They will be. And I will zoom back out so that you guys can make sure that yours is accurate. And then the only other thing that we need to do is tangent. Okay. Oops, wrong way, sorry. There it is. Okay. Now tangent we know to be sine over cosine, which is opposite over adjacent. And cosine also has a nice little pattern. On the 45s, which for me is my greens, tangent will always be 1. Depending upon the quadrant, it might be -1. Okay, so I can automatically go in and put 1 for my 45s. Second quadrant, tangent's negative, so it becomes a -1. Third quadrant, tangent is positive, and I'm just putting tangent underneath my sine and cosine. And the fourth quadrant, tangent is -1. Now the tangent, and I'm going to just solely go into the first quadrant. It's either going to be 1 over square root of 3 or square root of 3 for tangent. How do I remember that? I start with 30 degrees. 30 degrees is less than 60, and 1 over square root of 3 is smaller than square root of 3. Okay? So it's either 1 over square root of 3 or it's square root of 3. And because 1 over square root of 3 is less than square root of 3, I'm going to stick it with my 30 degrees. Now understand, this isn't the mathematical way in which we find these. These are the gimmicks so that you can create your unit circle quickly. The way we come up with these are our right triangles using our special rights, knowing that this central angle is 30 degrees. Opposite of that is 1/2. Adjacent to that is square root of 3 over 2. That's where these numbers are coming from. These are just little gimmicks. So then I'll transfer this. Tangent in the second quadrant is negative, so this becomes negative square root of 3. So go ahead, according to what tangent is and according to the colors that you used, fill in your square root of 3's and your 1 over square root of 3's. And then that will complete our unit circle.